Okay, so when we talk about basic roots, we're going to be looking at square roots, cube roots for the most part. And then there'll be some other roots we'll call nth roots. Okay, nth roots. Okay, so usually the directions will say something like this. So let's call this Roman numeral 1, and we'll just say simplify. And in number 1, let's say we want to look at the square root of 16. We want to simplify the square root of 16. Okay, so remember the square root, the square root of a number, the square root of a number, whatever that is right here, means this. Means what number times itself is 16. And the 16 here is called the radicand. So remember that word, radicand. Radicand. And the index, see there's no number right here, so that index is understood to be 2. That index, call this index is 2. The square root. So the index is 2. So I'm taking the square root of 16. The square root of 16 means what number times itself is 16. Well, that's an easy one because we know that 4 times 4 is 16. So the answer is 4. Square root of 16 is 4. All right, number 2, we have the square root of 25 divided by 9. 25 divided by 9. Well, I can rewrite this as the square root of 25 divided by the square root of 9. And the square root of 25, we all know that 5 times 5 is 25. So the square root of 25 is 5. And the square root of 9, 3 times 3 is 9, so the square root of 9 is 3. So the answer is 5/3. Okay, now keep in mind that we're dealing with square roots here. In the first 2 problems, those were square roots. Square root of 16, square root of 25 divided by 9. Let's look at number 3. I have the square root of a negative 9. So again, let's ask ourselves, what number times itself is negative 9? Well, there is no number times itself that's negative 9. Because if you think about it, negative 3 times negative 3 is not negative 9. Negative 3 times negative 3 is a positive 9. There is no number times itself that's a negative 9. So for right now, you're going to say that you're going to say no real number. You're going to say, let's put it like this, not a real number. Not a real number. All right, you cannot take the square root of a negative number because the radicand's negative. There is no number times itself that's ever going to be negative. Okay. Now, later on, probably in 2 weeks, you're going to learn about imaginary numbers. So you may remember that word from a previous course. Imaginary numbers, complex numbers. So you can learn about that in a couple of weeks. But for right now, on my math lab and on the worksheet, you're going to say the square root of a negative 9 is not a real number because no number times itself is negative. See, the square root of 16 is a real number because 4 times 4 is 16. The square root of 25 divided by 9 is a real number because 5/3 times 5/3 is 25 divided by 9. 5 times 5 is 25, 3 times 3 is 9, which is what the radicand is. All right, number 4. So number 4, you have negative square root of 121. And so again, square root, the radicand is 121. So you're going to ask yourself, let's go ahead and cover up that negative for right now. We're going to just cover this part up. So ask yourself, what number times itself is 121? Well, it's 11, right? 11 times 11 is 121. And so this right here is 11. But remember, you have a negative in front, so the answer is a negative 11. So a negative 11 times negative 11, see, I'm sorry, Um, excuse me. Let me do this over. Okay, so the square root of 121 is 11, right? So 11 times 11 is 121, which is the radicand. But there's a negative out in front, so you need to write this as negative 11. Okay, now let's just talk about, well, let's do one more and then we're going to talk about another idea. So let's say we had this 3 square root of 49. 3 square root of 49. Let's cover up the 3 for right now, just like with the negative. So remember, all we do is just bring down the negative. So we're going to cover up the 3. So the square root of 49, you're going to ask yourself, what number times itself is 49? Well, that's easy because 7 times 7 is 49. So that means that the square root of 49 is 7. But that is being multiplied by 3. So 3 times the square root of 49 means 3 times 7, which is 21. So the answer is 21. Okay, now before we move on into cube roots, I want you to notice something. This part was easy. Next week, it won't be as easy as what you see. This part was easy because all of the radicands, I want you to notice this, 16, 25 divided by 9, 121, 49, those are all perfect squares. Those are all perfect squares. Remember, your perfect squares, the smallest perfect square is 1. The next perfect square is 4. So here's how we're getting those perfect squares. Remember, 1 squared, 1 times 1 is 1. 2 squared, see 1 squared, 2 squared is 4. 3 squared, so notice the pattern. 1 squared, 2 squared, 3 squared is 9. The next one, 4 squared, 1, 2, 3, 4. 4 times 4 is 16. So these are your perfect squares right here. Those are your perfect, and they're an infinite. So the next one would be 5 squared, which is 25, and so on. So there's an infinite number of perfect squares. So what that means is this. If I take the square root of 1, I get 1. If I take the square root of 4, I get 2. If I take the square root of square root of 9, I get 3. Square root of 16 is 4. Square root of 25 is 5, and so on. So that's what these were. These were all perfect squares. 16 is a perfect square. Square root of 16 is the integer 4. Square root of 25 is the integer 5. Square root of 9, 9 is a perfect square. We just get 3, and so on. So those are perfect squares. Next week, they're not going to be perfect squares. So you got to do a few more things to simplify. Here, we're simplifying square roots in which the radicands are perfect squares. So that's the easy kind. And also where the radicand was negative. So remember, you cannot take the square root of a negative number. So for right now, we're going to say that's not a real number. So that was square roots. Now let's talk about cube roots. So let's do a few cube roots. So again, the direction is going to say simplify. Simplify. All right, so let's look at number 1. So let's suppose we had the cube root of 64. Cube root of 64. So right now, the way I want you to think about this is just like with the square root. So this is cube root. So the index is 3. Remember, that's your index. So your index is 3. Now, don't confuse that with this. So don't write it like this. Don't write this looking like this, because that is not, this 3 is not an index. To me, that right here means 3 times the square root of 64. So don't say this is this. So when you write radicals, make sure you write the index correctly. The index goes right above that little symbol right here. See how I have it? So don't put it in front. Because to me, that means 3 times the square root, and that's not what this is. All right, so don't write it like this. So you gotta write it as an index. Make it look like an index. Okay, so you're gonna say the cube root of 64. So the index is 3. So you just like you did the square roots, you're gonna say what number times itself is 64. Well, if you think about it, and it's okay if you use your calculator to help you with this, but here's how I want you to think about it though. So you may say, well, is it 3? Well, 3 times 3 times 3 All right, if you look at that, watch. So you're going to say this. You're going to put 3. Remember, 3 times 3 times 3 means 3 cubed, right? So you're going to say 3 raised, right here, to the third is 27. So obviously that's not true. So that's 27. I want something that will give me 64. Well, let's try 4. 4 times 4 times 4. So let's see if that works. Well, 4 times 4 is 16, right? And 16 times 4 is 64. So you know that's true. But on your calculator, you're going to say 4 raised to the third power equals 64. So make sure you know how to use your calculator. So the cube root of 64 is just 4. That's the cube root of 64. Cube root of 64 is 4 because 4 times 4 times 4 is 64. All right, number 2. So number 2, let's suppose you had the cube root of negative 125. Now be careful. So you may say, well, a while ago you said the radicand here was negative, so we had to put not a real number. Well, that's because I was taking the square root of a negative 9. So you ask yourself, what number times itself is a negative 9? Well, there is no number times itself. A number times itself is going to be positive or 0, never negative. But for cube root, it is possible to get a negative number. What number times itself 3 times is a negative 125? It is going to be a negative 5. A negative 5 times a negative 5 times a negative 5. Because watch. Let's do it this way. A negative 5 times a negative 5 is 25, right? A positive 25. A positive 25 times a negative 5, positive 25 times a negative 5 gives me negative 125. So it's negative 5. So the cube root of negative 125 is a negative 5. And there's your answer. So in terms of, see how the index is odd? The index is odd. So you can take the odd root of a negative number. You cannot, and get a real number. You cannot take the even root of a negative number and get a real number. It's going to not be a real number. So if this was 4th root, 6th root, 8th root, you would still say not a real number. Okay? All right, let's look at number 3. So number 3, we have the cube root of 512. Now you may need your calculator on that one. So let's ask ourselves, what number times itself 3 times is 512? Because that's what that means. So put something in there. We know it's not 5 because 5 times 5 times 5 is a positive 125, right? So let's try 6. 6 times 6 times 6. What is that? Well, use your calculator. 6 raised to the third power. So 6 raised to the third power is 216. So that's not going to work. All right, let's try 8. 8 times 8 times 8. So 8 raised to the third power gives us 512, which is what I wanted. So that is 512. So the cube root of 512 is 8. Cube root of 512 is 8. And then one more. So if I had number 4 like this, what if I had negative cube root of, let's say, 27? Negative cube root of 27. So you're going to do this. Now listen carefully. You're going to, just like we did before, you're going to cover up the negative for right now so you don't get confused. So the cube root of 127, you get to ask yourself, what number times itself 3 times is 27? Well, that's an easy one because you know 3 times 3 is 9 and 9 times 3 is 27. So that's 3 right here. But remember, just like previously, it's going to be a negative 3 as the answer. Now, what if this right here became this? Let's write this as number 5. What if I had this as number 5? Negative cube root of negative 27. Don't let that throw you off. Cover that outside negative for right now. So ask yourself, what is the cube root of a negative 27? What number times itself is a negative 27? Well, it'll be a negative 3 because a negative 3 times a negative 3 is a positive 9. And a positive 9 times a negative 3 is a negative 27. So this right here is a negative 3, but I have a negative in front of that. So what this means, see this is negative 3, but there's a negative in front. So the way you want to read this is this way. You want to think of this as the opposite of a negative 3. That's how you read this. Opposite of negative 3. Well, the opposite of negative 3 is a positive 3. So the answer is positive 3. All right, so be careful with the signs on some of these problems. All right, you got to remember some things from the previous courses, like this meant the opposite of a negative 3, and you know that the opposite of a negative 3 is a positive 3. Okay, now, these were cube roots, and notice that in all of these problems, sorry, let me go to the cube root one. So notice that in all the problems, I ended up with a nice integer. Cube root of 64, 4. Cube root of negative 125, negative 5. Cube root of 512, 8. Cube root of 27, 3. In this case, it was negative cube root, so you get negative 3 there. Same thing here. What this is the idea of perfect cubes. Perfect cubes. Perfect cubes. Let's talk about what our perfect cubes are. So the smallest perfect cube is 1. And you're going to do it just like you did these perfect squares. So you can say 1 squared, 2 squared, 3 squared, 4 squared, and so on. But this time you're going to say 1 cubed. Let me go ahead. I need some room here. So you're going to say 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed, and so on. So there's an infinite number of perfect cubes. But the smallest perfect cube is 1 cubed, 1 times 1 times 1, which is 1. 2 raised to the third power is 8. So there's your next perfect cube. 3 raised to the third power is 27. So there's your next perfect cube. 4 raised to the third power, 4 times 4 times 4 is 64. 5 raised to the third power is 125. 5 times 5 times 5 is 125. 6 raised to the third power, use your calculator if you need to. 6 raised to the third power is 216, and so on. So those are your perfect cubes, meaning that when you take the cube root of 1, you get 1. When you take the cube root of 8, you get 2. When you take the cube root of 27, you get 3, and so on. All right? Now, let's look at this. So let's say you wanted to approximate. Oh, and by the way, so next week, it won't be perfect cubes anymore. So next week, you're going to learn how to simplify cube roots where the radicand is no longer a perfect cube. So that'll be starting Tuesday, where this is no longer a perfect cube. So you won't get this nice number right here. But let's use a calculator to approximate a couple of them, because I'm on MATLAB there, and also on a worksheet, there are a couple of problems where you have to use your calculator. You need to make sure you know how to use your calculator. So let's approximate, let's say this one. So let's say you want to approximate the square root of 18. Now next week, you're going to learn how to simplify this without, because this is not a perfect cube. No number times itself is 18. But you can learn how to do that next week. For right now, though, I just want you to put that in your calculator. And the direction is going to say approximate to the nearest thousandth. Thousandth. To the nearest thousandth. So you're going to say this. Make sure you know how to use your calculator. So on my calculator, I've got to press the square root first. So the square root is right above the x squared. So I got to, can't see it right here. But for me, I got to go second x squared, and see you get the square root symbol. It automatically puts a parentheses there. So I'm going to say 18. I'm going to close the parentheses. So I'm taking the square root of 18, and then I'm going to press equal. So the square root of 18 is approximately equal to the nearest thousandth. You got to know your place value. This is the tenths place. The 4 right here is in the hundredths. The 2 is in the thousandths. And then the 6 is in the 10,000. So to round off, you got to look at the 10,000ths place. So since 6 is 5 or bigger, the 2 becomes a 3. So this is going to become approximately equal to 4.2 4.243. 4.243. All right, let's do a cube root. So let's say you want to find the cube root of 20. Let me do it better. The cube root, see that looks like an index now. The cube root of 23.82. Now, for cube roots, it's a little different. It's a little different for cube roots. Okay, now my calculator, right above that little white thing that looks like a roof, you can't see it, but it looks like this. You have this symbol that looks like this, right here. So we're going to use this. Now, when using this symbol, you got to put the index first. So on the calculator, you're going to say 3, since this is cube root. All right, so you're going to type in 3 just like this, and then you're going to type in this symbol right here. But to get 2, you got to press second, and then this roof-looking thing right here. You see how it shows up? So that symbol is this. Then notice this time it didn't put a parentheses in there, but it doesn't matter. You're going to say 23.82. So 23.82. Then press equal. So now I'm taking the cube root. Be careful, this does not mean 3 times. This means cube root. Cube root of 23.82 equals, and then to the nearest thousandth, tenths, hundredths, thousandths, you got to look at the 10,000ths. Since 2 is less than 5, the 7 stays 7. So this is going to be approximately equal to 2.877. All right, so that's how you can use your calculator. So just make sure for the worksheet in My Math Lab that you know how to use your calculator to approximate. Okay, now let's continue on. So on My Math Lab and on the worksheet, you may see something like this. You may see something like, and I'm going to just go ahead and put this as answer each of the following. All right, answer each of the following. So in My Math Lab, you may see something like this. Number 1, find the principal, P-R-I-N-C-I-P-A-L, principal square root of 144. Find the principal square root of 144. When you see the word principal, that means the positive square root. So all you're going to do is this. So what this statement means right here is this. You're taking the positive square root of 144. All right, and so the answer now is, what number times itself is 144? Well, that's 12. So the answer is 12. All right, so the principal square root of 144 is 12. Principal square root means you're looking for the positive square root. That's what principal means. Principal square root, positive square root. Compare that one with this one though. So this one's going to say find all square roots. Find all square roots of 225. Now listen to this discussion. So remember, you're finding the square root of 225. So you ask yourself, what number times itself is 225? Okay, so what number times itself is 225? Okay, so if you try to if you need to use your calculator to kind of help you with this, you could actually take the square root of 225. Let's just show you what I'm going to do. So the square root of 225, you get 15. So it's 15. So 15 times 15 is 225. So you're going to say, all right, well, the answer is 15. All right, well, that's true. The square root of 225 is 15, but it's not the only one, right? What about negative 15? Negative 15 times negative 15 is also what? 225. So number 2, where it says find all square roots, there are 2 answers, 15 and negative 15. So Find the principal means only the positive square root. Find all square roots means, square roots now means positive and the negative. All right. Now, you're also going to see something like this where it was going to say evaluate. So you may see the word evaluate. So let's look at I'm going to put this as number 1. So evaluate. So we have the square root of 81 minus the square root of 25. Square root of 81 minus the square root of 25. Well, the square root of 81, 81 is a perfect square. We talked about perfect squares a while ago. So that means that 9 times 9 is 81. So this is just 9 minus the square root of 25. Well, 25 is a perfect square, and so therefore the square root of 25 is 5. And so the answer, 9, this right here, is going to be 4. So the answer is 4. 9 minus 5 is 4. So that's number 1. Number 2, suppose we had the cube root of 64 plus 2 times the square root of 49. See, that means 2 times here. 2 times the square root of 49. So remember, if there's no index, it's understood to be square root. The index is understood to be 2. When dealing with radicals, no index has an index of 1. So if you don't see it there, that's a 2. So that's square root. So you have cube root of 64 plus 2 times the square root of 49. Well, the cube root of 64, what number times itself 3 times is 64? Well, that's just 4. Plus 2 times the square root of 49. What number times itself is 49? 49 is a perfect square. So that's 7. But 2 times 7 is 14. And 14 plus 4 is equal to 18. So the answer is 18. So there are a couple of problems where you're going to see things looking like this. So make sure you know how to evaluate each little part. So the worksheets for this week are fairly easy because all of these are going to be nice numbers that you're dealing with. It's next week where they will no longer be perfect squares or perfect cubes. Okay, so let's look at some other roots. Other roots. Okay, other roots. So let's say number 1, you want to look at the fifth root, that's 5, the fifth root of 243. And those are the easy kinds because this is going to be a nice number for us for right now. So in your calculator, just use your calculator for right now. Just kind of figure out, well, what number times itself 5 times? That's what it means. What number times itself 5 times is 243? Well, that's a little bit harder to kind of figure out. So use your calculator. So remember, on your calculator, you're going to use this symbol, right? So the x root, you're going to use this. So you got to type in the index first. So on your calculator, you're going to say 5 for fifth root, 5. Then you're going to press 5. Then you're going to press second, and then that symbol right here, and you get the root right here. But I want to take the fifth root of 243, so it'll be 243, and then press equal, and the answer is 3. This is 3. And it makes sense because 3 times 3 times 3 times 3 times 3 is, see, this is 9, right? This is 9, right? 3 times 3 is 9, and then times 3. Well, 81, 9 times 9 is 81, and 81 times 3 is 243. And that's what we wanted. All right, so the fifth root of 243 is 3. And then let's do one more with this. Suppose we had the fourth root. Okay, fourth root. So let's suppose we had the fourth root of 625. That's a little bit harder for some students to think about in their mentally. So there, what number times itself 4 times is 625. That's a little bit more difficult to do. Use your calculator. So fourth root. So you got to press 4 first. Okay, calculator. You got to press 4. So 4. Then you press this symbol right here. So you got to say second. That symbol. And then 625, and you press equal, and the answer is 5. So that's equal to 5. And then kind of makes sense because 5 times 5 times 5 times 5, see, that's 25. That's 25. And 25 times 25, 25 times 25 is 625. Okay? So that is part of Wednesday, I think, that you'd be looking at. So what we did so far was we discussed some basic ideas about square roots, some basic ideas about cube roots and nth roots, like fourth roots, fifth roots, and so on. Okay? So what we're going to do now, so I'm going to go ahead and end this part.